So for this day, we will going to talk about the Fibonacci sequence. So Fibonacci sequence, the human mind is hardwired to recognize patterns. In mathematics, we can generate patterns by performing one or several mathematical operations repeatedly. And so if we compare, as we remember in our previous lesson, that the nature recognized also with patterns as a human being, as a human perceive, and an object or as he recognized as the pattern, so we can from that thing we generate it by generating patterns. It performs one of general mathematical operations repeatedly. And so it is not only talk about the patterns or generating patterns, but as we observe those patterns, we can also understand the mathematical operation continuously. So what does it mean? For example, suppose we choose the number 3 as the first number in our pattern. We can choose to add 5 to our first number, resulting which is 8, which is our second number. Repeating the process, we obtain 13, 18, 23, and 28 as the succeeding numbers that form our patterns. So as we can see here, we have here 5. Based on the explanation earlier, for example, we choose number 3. So number 3 and we try to add number 5, then we have the result of number 8, which means we have the first 3. If we try to add 5, then we have 8. Supposedly 8 are a second number because our first number is 3. As we add 5, our second number now is 8. The second example, we use second number to add again 5, then we have the result of 13. So therefore, from 3, 13, and we have 5, also patterns of 18, 23, 28, and so on and so forth. So this type of example is what we call the sequence or the intervals. First sequence is an ordered list of numbers called term that may have repeated values. The arrangement of these terms is set by definite rules. So those for the sequence, as we can see on our previous example, that we always add 5 to have the succeeding numbers or the number after we got the result. For example, we have here number 3. Since we add number 5, then the result is 8. So the result here, since we have the result here or the second number, we add again by its interval or what's so called the term. So if we add 5, which is term, so we have 13, and we use again number 13, then we have again number 5, we have result of 18, and again 5, we have the result of 13, and so on and so forth. So that type of example is what we call sequence. Remember, if we talking about the sequence is an ordered list of number and also arranged by those on the set by a definite rule. So how do we generate a sequence? For example, we analyze these numbers, analyze this given sequence for its rule, and identify the next 3 terms. So we have here 1, 10, 100, and 1000. So how do we find the next sequence? So the solution here, looking at the set numbers, it can be observed that each term is power of 10. So it means if we have here result of 1, then by the use of power of 10, which is term. So we have here 10 raised to 0 is equal to 1. Then 10 raised to 1 is equal to 10. And 10 raised to 2 is equal to 100. And 10 raised to 3 is equal to 1000. So as we can see here, only the numbers of the exponent and starts from 0 as then 1 comes with number 2 and number 3. So it's possible that the next term, that the next number is we need to find, or the next 3 terms we need to find is the number 4, the number 5, and number 6. Since we have here the pattern, since we have here terms are the we have the pattern of the series starting from 0, 1 to 3. So the next 3 terms are the number of 4, 5, 6. So if we simplify them, raised to 4 is equal to 10,000. 10 raised to 5 is equal to 100,000. And then 10 raised to 6 is 1 million. So that's how we generate a sequence by analyzing the sequence or the given sequence for define on roll. How about this one? We have here 2, 5, 9, 14, 20. So at first, how do we understand or how we analyze the sequence given here? So the solution there is the difference between the first and the second terms is equal to 3. So if we try to subtract 5 to 2, then we have the result of 3. So the difference between the second and the third terms, which is 9, minus 5, we have 4. And then the difference between the third and the fourth term, which is 9 and 14. If we subtract 14 to 9, then we have the result of 5. And then the difference between the fourth and the fifth, if we subtract 20 to 14, then we have 6. So this is a term that is used in this kind of sequence. So how about if we follow the rule, or if we follow the rule, it can be deducted that to obtain next 3 terms, we should add 7, 8, 9, and so respectively to the current term. Hence the next 3 are 20 plus 7, we have 27. 27 plus 8, we have 35. 35 plus 9, we have 54. They are also the same by adding the counting numbers, like 2 plus 3 is equal to 5, 5 plus 4 is equal to 9, and 9 plus 5 is equal to 14, 14 plus 6 is equal to 20, and so on and so forth. So that we come up with this kind of sequence, or the generate the next 3 numbers or the next 3 terms, which are 27, 35, and 54. So while we are talking about the Fibonacci sequence, who is the proponent of the Fibonacci sequence? Fibonacci sequence is named after the Italian mathematician Leonardo of Pisa, and who was better known by his nickname Fibonacci. And he said to be discovered the sequence as he looked at how a hypothesized group of rabbits bred and reproduce. So how Fibonacci sequence works? Um, Fibonacci sequence starts with 0 and 1. The succeeding terms and the sequence can be generated by adding the two numbers that came before the term. And super example, we have here 0 plus 1 is equal to 1. Then we have here a sequence of 0, 1, and 1. Then 1 plus 1 is equal to 2. Then the next term is equal to 2. 1 plus 1 is equal to 3. Then the next term is 3. Then 2 plus 3 is equal to 5. Because the numbers from the previous sequence is this 1, 2. So that we add number 3. So we add number 5, and 3 plus 5 is equal to 8, and 5 plus 8 is equal to 13. So if we try to table all of this sequence, then this will be our final sequence, which is 0, 1, 1, 2, 3, 5, 8, 13. So 0, if we add 0 plus 1, then result of 1, and 1 plus 1, we have 2, 1 plus 2, we have 3, 2 plus 3, we have 5, 3 plus 5, we have the result of 8, 8 plus 5, we have 13, and 8, 13, which is the next term, and so on and so forth. So that is the patterns in Fibonacci sequence based on Fibonacci. And